The concepts of map scale and metadata are something you will commonly hear when working with GIS, so I think it is important to describe them for you and make sure that we are all on the same page when talking about them. The word scale has different meanings depending on the context in which it is used. For example, you might have heard a person use the word scale when referring to scales of geographic phenomena, or about the scales at which phenomena are represented on a map. Or probably you have heard the word used as a verb, as in scaling in map or downscaling. Scale bars are important elements on maps because they provide a visual representation of the relationship between the distances on a map and the corresponding distance in the real world. For example, often scale is used as a synonym for scope or extent. The title of an international research project called the Large-Scale Biosphere-Atmosphere Experiment in the Amazonia uses the term large scale to describe a comprehensive study of environmental systems operating across a large region. This usage is commonly not only among environmental scientists and activists, but also about economists or politicians. Those of us who specialize in geographic information systems usually use the word scale differently. When geographers use the word scale, they usually refer to the sizes of things that appear on a map relative to the sizes of those things on the ground. So basically, we're talking about the relationship that an object, in other words, that the peak feature on a map has to its actual size in the real world. All maps are model representation of the real world, and therefore an object on a map or features are reduced in size when mapped. And there are three types of scales. The first type is the verbal, and if you read it, it says that 1 inch equals to 15,000 meters, meaning 1 inch represent 15,000 meters in real life. The second is the ratio or fraction, which means that everything on a map is 15,000 times smaller than what it is in real life. For example, here you can see that everything you see on this map is 15 million times smaller than in real life. The last one is probably the most difficult to understand, but at the same time is simple. What it means here is that the distance of 1,000 miles will be from here to here, and we can measure anything on this map using this scale bar. So you can see the different types of scales that can be used on a map. Now I would like to show you something interesting, which is this map that is the oldest surviving map that includes scales. It is the Tabula Rogeriana, and it was created by the Arab geographer Muhammad al-Idrisi in 1154. And this map was drawn on a silver tablet that depict various regions of the world with a system of latitude and longitude lines, but also it included a scale bar. So since maps are described as either large scale or small scale, we have to understand what they mean. When we talk about small scale maps, it means that we are showing a larger geographic area with few details on them. And here you have an example. This is a small scale map. When you're talking about large scale maps, you're showing plenty of detail on those maps. So here we're showing from small scale to large scale. And this is a great summary of how scale relate to geographic extent. When we're seeing maps that cover the global extent or a global extent of a phenomena, we're talking about small scale. And we're talking about low accuracy or detail. And we're talking about a geographic extent that is, for example, a municipal or town or something like that, the scale will be large. So we're talking about large scale map with high accuracy on the map. So when we talk about data, let's say we're looking for data sets for our projects, usually small scale data, those that represent data at a global scale are relatively easy to find. But when we're talking about large scale based data, or as I mentioned here, very large scale, it is quite difficult to find because it is very localized. And usually towns, for example, might be using data that is generated at a state level. Now, when we're talking about very specialized data, let's say geology, they typically can be found only small scales. That is data that will cover large regions with not a lot of detail. And I'll show you one example. Now, there are different source scales. Data come at many scales, and we need to find the data at suitable scale for our projects. There are a couple of types of scales. The map scale, which is what we have already seen, what I have explained, which is the scale of the produced map. But also there's data scale, which is the scale of the individual data sets. So when we work with maps or when we work with GIS, we work with different data sets, and each one might have a different scale. So I'm going to show you an example. There's an initiative called Open Spatial Demographic Data and Research, and this data is an open source demographic data sets. It's called WorldPop, and they develop high-resolution geospatial data. Now, high resolution at the global scale means that we have demographics or population density that have spatial resolution of either 100 by 100 meters, meaning that each one of the pixels represents a total number of population, let's say population count, but the size of that representation will be 100 by 100 meters. Or also we can find data sets that are 1 kilometer by 1 kilometer grid cell, meaning that the size of the pixel will be 1 kilometer by 1 kilometer. So in short, we're talking about small scale data representing demographics at the country level, where each pixel could be 100 by 100 meters or a square kilometer grid cell. Now let me show you how it looks. I'm going to go to data to download the data for India of, let's say, population counts. This is basically some sort of metadata that explains how every single layer has been created, how these models were created. So I'm going to go for the unconstrained individual countries UN adjust 1 kilometer resolution. I'm going to look for India. Here it is. And I'm going to pick the 2020 population, click on data and resources, scroll down and go to the data files right here. And we have two types of data. This is a zip file and this is unzip. So I'm just going to download the TIFF file. It is a raster data, and I'm going to save it. I'll save it in downloads, save. And the other one I'm going to save is the 100 meter resolution, UN adjust as well for India. Here it is. I click on data and resources. I scroll down and go to the download entire data set, which it gives you is quite heavy, but I'm going to still download the file. So the files are in downloads, and I'm just going to connect a folder here so I can upload or import those files into the ArcGIS Pro. So I just right click on folders and I'm going to connect the folder downloads. So I just select it and click OK, and I will see the folder downloads right here. So this is one of the files that I'm downloading. This is the 1 kilometer aggregated population counts. Right click, add to current map, and here it is. It is a raster. So if you remember, raster data is data that is based on pixels. So it consists of a matrix of cells. So if I turn off states, you will be able to see the raster data and countries as well. And you can see here the pixels, right? These squares that you see. If I click in each one of them, I'll see the population count per pixel. So every time I click somewhere, it will change the number. It's giving me the population count in that particular place. Now I'm going to add the other layer. Now it appears here, it has finished download. So I'll click on add to current map. This is the layer. You can't see it right now because the other one is turned on. So I'm going to turn it off. There you go. You can see the difference in data scale. So the data scale is different. One of them is 1 square kilometer. The other one is 1 hectare. So 100 by 100 meters. So this is how you can see the data scale. Or you can also look into the metadata as I showed you before. Again, this data will contain population count per pixel, and you will see it right here, but the data scale differs. Now this is for raster. Now let's see for vector data. So I'll zoom out so I can see the coastline. So let me zoom out a little bit more so you see this is India, this is the coastline, and let's just look into this area right here. The data scale of both layers, countries and states, also is different. For states we have a large scale data sets. For countries we have small scale data set. You can see the difference in the resolution. So now you can see how data source scale affects representation. The larger the scale of the map, the better the features that can be detailed. So the GIS data has a source scale. This will impact what you can do with it. And it is important then to understand the spatial questions and the scale of the spatial information that you will be using to answer those questions. Now, when we're looking for data, we always look at the metadata to understand the data scale, right? But unfortunately, only 30% of GIS data documents the source scale. Usually we don't find that information unless we dig a little bit more and try to either contact the source of the information or try to find out that by ourselves. Now, we have already talked about metadata, and we know that that's the data about the data. It contains information about the data itself to understand how it was created and what's the quality of it. Now, let me show you a final example. I opened 3 different websites. The first one is the Humanitarian Data Exchange. I looked for information about Syria, and I'm just going to pick any data set. So for example, I will filter to shapefiles. I'll click here on shapefiles, and I'm going to look into the subnational administrative boundaries. I click on top of it, and it's going to take me to the data set. That's where you download the data set, but also it contains metadata. This is the metadata that it's provided for that particular file, which it doesn't show much information. It just says who's the source, who's the contributor, which the Humanitarian Data Exchange, basically they are those who compile the data, and then when it was last updated. This is one example of metadata. Another one is this geoportal for Maine, the state of Maine here in the US, and they have a list of layers. Here is the service, and then the data type. This is a KML, this is a shapefile, and at the right side of it is the metadata. Okay, so if you click on metadata, it will open the metadata, which is this one. There's the description and the terms of use. And the last one is the major mineral deposit. This is a layer I found in USGS. And here's the brief description, a format, how you can download the data, and the metadata. So I'm going to click on outline. So that's how you can look for metadata whenever you're downloading data, which is going to allow you to see the quality of the data, the scale, the data scale, etc.